In this video, we are going to study the concept of cumulative distribution function for discrete random variables, or short for CDF. As we will see later in this course, when we will study continuous random variables, we will see that expectation, variance, measures of spread, and measures of central tendencies, they are going to differ for discrete and continuous random variables. For that reason, it would be nice to have some concept, some function that will work the same for both discrete and random variables. Now, a CDF is defined as follows. Notation is uppercase letter F, subscript the name of our random variable. It is a function of some small x, and is defined as probability that our random variable x takes on a value less than small x here. So CDF is well defined for both discrete and continuous random variables. So as we will see later in this course, CDF for continuous random variables will have the same notation, the same definition. Now, let's take a look at the following example. Let's assume that the PMF of random variable x is given as follows. It takes on a value of 1 with probability, let's say 1 over 4. It takes on a value of, let's say, 3 with a probability of 1 over 2. So on y-axis here we have our PMF, small f of x, and it takes on a value of 4 with probability of 1 over 4. Now let's try to use our definition here and to plot the graph for CDF of random variable x. Now here is a plot of CDF. On y-axis we are going to have the value of our CDF. On x-axis we'll have values of x. Now for all values less than 1, we have 0 probabilities here for PMF, meaning that for all values lesser than 1, the value of CDF is also going to be equal to 0. Now at point 1, let's take a look at the value of our CDF at point 1. It is a probability that our random variable x are less or equal than 1. Probability that our random variable x is strictly less than 1 is equal to 0, no probability there, plus probability that random variable x is equal to 1, which is equal to 1 over 4. So at this point here, at point x is equal to 1, our function, CDF function, is going to make a jump to 1.4. Now, let's consider any value, let's say, to the right of 2 here. Now, there are no values for PMF of our random variable x there. So up to this point here, 3, our function is going to remain constant on that interval from 1 to 3. Since let's assume we are looking for value of PMF of x at point, let's say, 2.3. This is probability that x is less or equal than 2.3. So we only have a value of probability x being equal to 1, which is equal to 1 over 4 at point 1 there. So this is equal to probability that x, let's say, let's define it as follows. So probability that x is less than 1 plus probability x equal to 1 plus probability that x is strictly greater than 1 or less or equal than 2.3. All right, now as this here is 0, that here is 0, and this value here is equal to 1 over 4. So this is equal to 1 over 4. So for any value in interval from 1 to 3, our PMF is going to remain constant. Up until this point when x is equal to 3. At x equal to 3, probability that x equal to 3 is equal to 1 over 2. So we'll have to sum 1 over 4 plus 1 over 2 to get a value of 3 over 4 for PMF at point 3. So 3 over 4. So our function is going to make another jump at this point x is equal to 3. And similarly, let me erase that. And similarly, our function is going to remain constant up until point 4 here at a level of 3.4. If the value of x is equal to 4, our function is going to make yet another jump up to the value of 1 over 4 plus 1 over 2 plus 1 over 4, which is equal to 1. Now, if we take a closer look, we can notice that our function is now going to remain constant up until to plus infinity for all values greater or equal than 4. The value of our CDF is going to be equal to 1. Right? So if we select any value, let's say PMF of x of 5, it is going to be equal to PMF of x of, let's say, 100, and will be equal to 1. Right? So probability that our random variable x is less or equal than 100 is equal to 1, since all values our random variable can take on are less than 100. All right, now this concludes our video on CDF of discrete random variable.